Welcome. These are your Integrated Math 2, Section 2.2.1 notes. Our topic is right triangle trigonometry. Our learning targets are 1. Given an angle of reference, I can determine the opposite side, adjacent side, and hypotenuse of a right triangle. And for 2, it's given one side length and an angle of reference, I can find the appropriate trig ratio. So up here we have two examples. We have basically two of the same right triangles here, but we're going to use two different angles of reference. So in this problem, 42 degrees is my angle of reference. So this is the angle we're talking about. And the first we need to determine is what is the hypotenuse. So you put your finger on the right angle, the side you're not touching is always the hypotenuse. So this side is my hypotenuse. Then, to determine your opposite side versus adjacent side, you take your thumb, you put it on the angle of reference, and the side you are not touching is called the opposite side. So this side over here would be our opposite. When I put my finger on the angle of reference, you're touching two sides, right? One's the hypotenuse, the other side you're touching is the adjacent side. Adjacent next to the angle of reference. All right? And we did this in class, so you should have this down if you were in class that day. The next triangle, we're going to use the angle 48 degrees here as our angle of reference. Now, does my hypotenuse change? No, hypotenuse is still the side across from the right angle, so this is still my hypotenuse. But take note of the opposite and adjacent sides. If I put my finger on the angle of reference, the side I'm not touching is this side, so this becomes my opposite side, and this side down here becomes my adjacent side. Okay? So why is that important? We're going to be looking at trig ratios, sine, cosine, tangent, which use two of those three sides, and it's all based on the angle of reference. If you think about it, we have three sides. There are potential to have 6 different ratios that you can have. You could have opposite over hypotenuse, hypotenuse over opposite. You could have opposite over adjacent, adjacent over opposite. You could have hypotenuse over adjacent, adjacent over hypotenuse. Right? 6 different ratios are possible. We're going to be using 3 of those ratios. They're going to mean something to us in this class. Okay? So let's try it. So the first thing, how you're going to learn these ratios, how you're going to memorize them. A great way is so, ka, toa. So the first letter stands for the trig ratio. S stands for sine. C stands for cosine. T stands for tangent. And then the ratio itself, OH, it's opposite over hypotenuse. So sine ratio always equals the opposite over the hypotenuse. Over here I should give you my angle reference. This is going to be our angle reference here. Then ka, adjacent over hypotenuse. Cosine is adjacent over the hypotenuse. Toa, tangent, is opposite over adjacent. Opposite over adjacent. So you need to get these ratios down. And we're going to use them. So get these down in your notes before we go to the next section. So now I have a triangle here. 30-degree angle is going to be my angle of reference. So if I look at this, I know that finger on right angle, that's my hypotenuse. So always the largest side. You could also do just by looking at the numbers. And my opposite is this side here, because finger on the 30, opposite side. And then my adjacent is the 17.32 side. All right, so what's the sine of 30? Sine of 30 degrees is going to be opposite over hypotenuse. So opposite is 10 over 20. Okay, can we convert 10 over 20 into a decimal? Sure. Or that's going to be what? 0.5. 0.50. All right. Cosine of 30. So ka, adjacent over hypotenuse. So I'm going to put the 17.32 over the 20. So it's 17.32 over 20. Or can I convert that to a decimal? Sure. Not quite as easy to do in my head though. So I'll use my handy dandy calculator here. I'm going to go 17.32 divided by 20. And I get about 0.866. All right. Then the tangent of 30, TOA, opposite over adjacent. So opposite over adjacent, my tangent of 30 is going to be 10 over 17.32. 10 over 17.32. Which is going to be about 0.5774. And I like you to go, unless there's zeros afterwards, I like you to go 4 deep as far as your decimal places go for your trig ratios. Okay, to be very precise in our class. All right, so those are our trig ratios for this. So what does that mean? Every time you have a triangle, and you have a right triangle, I should say, with a 30-degree angle of reference, we know that the opposite over the hypotenuse will always be a 1-to-2 ratio, right? So if this was 100, this would have been 200. If this was 1,000, this would have been 2,000. That always has that ratio. Think about it, it really is the same idea as similar triangles. So we're not just picking the ratio of corresponding sides, we're doing the ratios of the opposite over the hypotenuse, okay? This also matches what we learned with special right triangles when we did 30, 60, 90, right? Which the short, this would be the short leg, and the hypotenuse was double the short leg. I use the same one on purpose so you see that connection. All right, cosine of 30 degrees, that ratio is always going to be 0.8660 to 1. All right, so what that means, if this was just 0.866, this is 1. If this was 8.66, this is 10. If this was 86.6, this is 100. It's always that 0.866 to 1 ratio. And then the tangent of 30 is 0.5774 to 1. So again, this side is 0.5774, this side's 1. If this is 5.774, this is 10. This is 57.74. This is 100. It always has that ratio for every time you have a 30, 60, 90 triangle, and 30-degree angle is the angle of reference. All right. So now you're going to be given, a lot of times you'll be just given 2 sides to say, what trig ratio is this? So here's our angle of reference. I identified it with the blue marking for the angle. All right, so you got to figure out what do we have here. All right. This would be the opposite side. This side is the hypotenuse. So, TOA, I'm using O and H. Which one uses that? So, yeah, so does. O and H. And it's opposite over hypotenuse. So we'd say the sine, I'll call this angle X, the sine of X equals 6 over 11, or we could get that decimal number, 6 divided by 11, 0.5454. 0.5454 to 1. Okay? Next one here, what are my sides that are given? Here's my angle of reference, we'll call it Y. Ooh, put my finger on it. Opposite, I don't have opposite this time. So we're not going to use opposite, but I have the adjacent and I have the hypotenuse. So think TOA. Which one uses A and H? That's right, cosine does, right? So this is going to be the cosine of Y equals what over what? 9 over 13. Or, use your calculator. Try to use my calculator. Clear. All right, there we go. 9 divided by 13 is 0.6923. All right, so that would be our cosine ratio for this triangle with angle y. And then finally we'll do angle z. What side's given? Finger on the angle reference. This is my opposite. This is my adjacent, because that's the hypotenuse. We don't have anything for the hypotenuse, so we're going to use the adjacent. So we're going to use those two sides. So again, SOHCAHTOA. We want to use opposite and adjacent. That's the tangent ratio. So we're going to say the tangent of angle z equals 8/7. Or 8 divided by 7 . 1.142. It's 8/5, so I'll make it 2.9. All right, so that would be my tangent ratio. It's 1.1429 to 1 for the opposite over the adjacent. So that's our trig ratios. Now, to actually find these values here on your calculator, you should have a scientific calculator, and you just type in sine of 30. Some calculators you hit sine and then hit 30. Others you hit 30 first, then you hit the sine. You got to figure out your calculator. We can also do this on Desmos. So I want to show you Desmos real quick. The Desmos calculator is here. The first thing you have to do, whether you do it on your scientific calculator or you do it on Desmos, is you have to make sure you're in degree mode to get the right ratios. So in Desmos, we go up to the wrench and see how it says radians and degrees. We're going to click on degrees. All right. So then we come up here and we can type in the sine of 30. Let me go to my keyboard. Sine 30 degrees, and it gives the answer 0.5. I can do cosine 30 degrees, and it gives me cos 30, gives me the answer there. And then we can do the tangent of 30. So the tan of 30, and there's our answers. So let's take a look. These are the same ratios we found before: 0.5, 0.866, 0.577. Let's look at what we had. Yeah, we had 0.50, 0.866, 0.5774. So we had the same ratios. So you can find those with your calculator, and we'll be using these ratios to find missing sides of a right triangle. So what's going to happen is you're going to be given an angle of reference and one side, and you're going to be able to find the missing side length using your trig. We'll be setting up a proportion and doing that, but that will be another video coming up soon. Thanks for watching.